Depleted uranium is uranium that has a lower content of U-235 than natural uranium and is a byproduct of the uranium enrichment process. Natural uranium contains about 0.72% U-235, while the depleted uranium used by the Department of Defense contains 0.3% or less. Depleted uranium is about 60% as radioactive as natural uranium, and its main component is the non-fissile U-238. Depleted uranium has various uses in civilian and military applications, mainly due to its high density, but it does have other favorable characteristics. In the civilian sector, depleted uranium is used as counterweights and radiation shielding for medical devices and containers used for transporting radioactive material. Military uses of depleted uranium include armor plating and armor-piercing projectiles. The most commonly used depleted uranium penetrator used in the U.S. military is the 30mm PGU-14B armor-piercing incendiary round fired mainly by the A-10 Warthog. Depleted uranium is preferred as a penetrator because it is self-sharpening and flammable. When impacting a hard target, the nose of the rod fractures in such a way that it becomes sharper, and this prevents the mushrooming effect that you get with tungsten penetrators. Depleted uranium penetrators are 20% more effective than tungsten. Additionally, the impact and subsequent release of heat cause the cloud of metal dust to ignite when it contacts oxygen. When a depleted uranium penetrator reaches the inside of an armored vehicle, it sets it on fire. The use of depleted uranium munitions is controversial because of long-term health concerns. The aerosol powders produced by the impact and combustion of depleted uranium can potentially contaminate wide areas, potentially being inhaled by humans. Additionally, several studies using cultured cells and laboratory rodents suggest the possibility of leukemogenic, genetic, reproductive, and neurological effects from chronic exposure to depleted uranium. Al Jazeera has claimed that depleted uranium from American artillery is suspected to be one of the major causes of an increase in the general mortality rate in Iraq since 1991. And in 2005, a study found that individuals exposed to depleted uranium had a higher likelihood of their offspring being born with birth defects. Depleted uranium was originally stored as an unusable waste product in the hope that improved enrichment processes would come along so they could extract the rest of the U-235. This re-enrichment recovery of the residual U-235 is practiced in some parts of the world, and it is actually possible to design civilian power plants that use depleted uranium, but only about 10% of those ever built use it because it expends a greater amount of nuclear waste. In 1996, the International Court of Justice ruled that depleted uranium munitions were not banned by the Hague Convention sections regarding poison, but later in 1996 and again in 1997, two additional resolutions were passed. They listed weapons of mass destruction, weapons with indiscriminate effect, and weapons of a nature to cause superfluous injury or unnecessary suffering, and urged all states to curb the production and spread of such weapons. Depleted uranium was included on that list.